Hello Year 11. So today I'm going to be going through some questions about the sine rule and the cosine rule. So this is a topic that came up on your recent paper, one of the recent mocks you did, the 3H mock. So just to recap, the cosine rule is useful when, say, you know all three sides of a triangle and you want to work out one of the angles. Or it's useful if you have two sides and an angle and you want to work out the other side. Um, the sine rule is useful because if you have, say, this side, this angle, and this angle, you can then work out this side. And vice versa, if you have this side, this angle, and this side, you can then work out this angle. So I'm going to be going through some questions, and the first one is this one, which is the question from your paper. So what this question is asking us to do is to work out the length of DC, this side, to three significant figures. And the first bit of information it gives us is about the size of angle DAC and the size of angle BCA and how they're related. So angle DAC, right, so that's this angle, which I'm going to call X, and angle BCA, which is this angle, which I'm going to call Y, are related. And what we're told is that X is equal to 2 over 5Y. Okay, so what can we do here? Well, in this big triangle, ABC, we've got all three sides. So what we can do is we can work out an angle. And what one do we want to work out? Well, we want to work out DC. So what would be useful is if we had this angle. And because we know that these two are related, we can either work out this angle or this angle first. And again, because of the cosine rule, we have all three sides. The angle we can work out is this one. Okay, so let's do that. How do we do that? Okay, well the cosine rule tells us that 3.4 squared is equal to 6.1 squared plus 6.2 squared minus 2 times 6.1 times 6.2 times cos of y. So what we can do is we can rearrange this equation and say that cos of y is equal to 6.1 squared plus 6.2 squared minus 3.4 squared divided by 2 times 6.1 times 6.2, okay, which is roughly equal to 0.8473. And then we can do the inverse cos of that with our calculator. So again, all these questions today are going to be calculator questions. They're all from calculator papers. So we can do inverse cos of this and get that y is roughly equal to 32.08. So we know this angle, which means we know this angle because x is equal to 2/5 of y. So that's roughly equal to 12.83. And then this angle, which I'm going to call z, is equal to 180 minus x minus y, which is roughly equal to 135.09. Okay? So what have we got now? We've got this triangle, we've got all three angles, and we have one side. And what we want to know is this side. Well, now we can do it. We can just use the sine rule. And the sine rule tells us that DC divided by the sine of the opposite angle, which is x, is equal to 6.2 divided by its opposite angle, which is sine of z. Yep. So we rearrange this and get that DC is equal to 6.2 divided by sine of z times the sine of x. And we've got x is 12.83, and we've got z 135.09. So we put that into our calculator, and we get that DC is roughly equal to 1.950343. And then to three significant figures, it's just 1.95. Okay? Pretty straightforward, so long as you know the sine and the cosine rule. So if you didn't quite follow that, go back, watch it again, and then let's see if you can do the next question. So this is the next question that we're going to have a look at. Now, what I want you to do is pause the video, have a go at the question, and then come back, and I'm going to work through the answer with you. Right, so let's go through this question. So this question is asking us to find out the perimeter of the shape that we've got here. And we know that this is a circle, and this is a triangle. So if we want to work out the perimeter, we have basically three sides that we want to work out. We want to work out this side, we want to work out this side, and we want to work out this side. And we're actually told that AD is 14. Okay, well we can cross that one off straight away. That's 14 centimeters. So we need to work out the other two. I'm going to start with the circle because I think it's the easiest one to do. So the circle, we're told the angle AOD is 140 degrees. That's this angle. Okay, so that means that this angle, this bigger one, is 220. And we know that the circumference of a circle is equal to pi times its diameter. And we're told that the radius of the circle is 6 centimeters, which means the diameter is 12. So the circumference of this, of the whole circle, would be 12 pi. But we're not interested in the whole circle, we're just interested in this portion of it. And this portion of it is equal to 220 over 360ths of it. So that's 220 over 360 times 12 times pi. Now why is that? So we've got 220 degrees here out of the whole 360. So we can basically say that this portion of it is 220 over 360 of the whole diameter. Okay? So this bit is equal to this, which is 22 over 3 pi. So then the last bit we need to work out is CD. Okay? So what do we know? We know the radius of the circle is 6, so we know this side, this bit here is length 6. That's just O to C, right? And similarly O to A is also 6. And what do we have here? Well, we have this side and this angle, and we want to work out this side. But we're also told the angle OAD is 24 degrees, which is this angle. So we can use the sine rule. And what we know is that 14 divided by sine of 140 is equal to OD divided by the sine of 24. Okay, which means that OD is equal to roughly 8.861. But we're not interested in the whole length of this line. We just want this bit sticking at the edge, which is the whole length minus O to C, which is the radius, so it's 6. So CD is equal to OD minus 6, which is roughly equal to 2.861. And then we worked out all three sides. So the perimeter is simply 14 plus 22 over 3 pi plus 2.861, which is roughly 39.8997. And the question wants three significant figures, so it's just 39.9 centimeters. So hopefully that's the answer you got, and hopefully you used the same reasoning that I did. If you didn't get the same answer, rewind the video or see if you can figure out where you went wrong in your calculation, watch my explanation again and see if you can follow it, and then try the next question. So this is the next question, and again what I want you to do is pause the video, try to do the question, and then come back and we'll work through it together. And for this question what we want is we want to work out the length of AD, okay? And we can see that in this triangle here we have an angle and a side. So if we could maybe figure out this side, we could use the cosine rule with this side, and this angle to figure out this length. Okay, so let's see if with this triangle we can work out BD. And looking here, we've got these two angles, and we've got the opposite side to this angle, which means we can use the sine rule. We know that 12.5 over sine 109 is equal to BD over sine of 34, which means that BD is equal to 12.5 over sine 109 times sine 34. And if you put that into a calculator, you'll see that this is roughly equal to 7.39. And then we can use the cosine rule. We've got 7.39 here, we've got this side and this angle, which means that AD squared is equal to 11.4 squared plus 7.39 squared minus 2 times 11.4 times 7.39 times cos of 86. Okay, so you put this into a calculator, okay, and then you square root it, and the answer that you get should be that AD is equal to roughly 13.147 something, and we want correct three significant figures, so that's equal to 13.1 centimeters. So hopefully that's the answer you got. If it's not, see if you can figure out where in your calculations you went wrong. Did you do this calculation wrong? Did you forget to square root it? Did you just type this into your calculator wrong maybe? Go over the question again if you didn't get it right. If you did get it right, we'll go on to the last question, which is this one. And again, what I want you to do is pause the video, try to do the question, and then come back and we'll work through it together. So in this question we want the length of AB. And we're told a little bit of information about these triangles. We're told that the area of the lower one is 56. And then we have these angles and the length of this side. So you should know from trigonometry that one of the ways we can work out the area of a triangle is half AB sine C, which would be a half times, for instance, this length and this length times the sine of this angle. Okay? So in this case what we have is a half times 11 times CD times sine of 105, and we know that that's equal to 56. So we can rearrange this to find the length of CD, and if you put that into a calculator, what you should find is that CD is equal to roughly 10.54. So we have the length of this side, we've got the length of this side, and we've got this angle. So we can work out the length of AC using the cosine rule. We get that AC squared is equal to 11 squared plus 10.54 squared minus 2 times 11 times 10.54 times the cosine of 105. So you do that calculation, you square root it, and you should get that AC is equal to roughly 17.091. So we've got this side and the opposite angle, and we've got this angle, and what we want to know is the length of this side. so we can just use the sine rule. In this case, AB over sine of 48, because it's the opposite angle, is equal to 17.091 over the sine of its opposite angle, 118, which means that AB is equal to 17.091 over sine of 118 times sine of 48. So you do that in your calculator, and what you should get is about 14.3856. To 1 decimal place is equal to 14.4 meters. So hopefully that made sense to you all. If you did struggle with any of these questions, just go over them again, see if you can figure out what it is that you're not getting, and just try and remember these two rules, the sine rule and the cosine rule.